Hello. The paper title for this conference is Analysis and Rendering of Deauthentication Attack Using IoT Technology. And our paper number is 22. And authors for this paper are Abhay Agrawal, Isha Arora, and Professor Animesh Giri, respectively. The paper arose due to vulnerabilities present in the modern day wireless standards and IEEE 802.11 protocols. So the vulnerabilities such as deauthentication frames, packet sniffing are serious threats to modern day wireless LAN, WAN, and ad hoc networks. So we propose to build a product that will be useful in exploiting these vulnerabilities in wireless networks. Wireless local area network is the most used communication network in smaller areas such as houses, schools, and offices. These networks follow security such as WEP and encryption, but there are still vulnerabilities in the lower layer of the protocol stack. The vulnerabilities in IEEE 802.11 have proved to be a medium for denial of service attack. Due to susceptibility of management frames, these networks are vulnerable to MAC based denial of service attacks. So, the result of these attacks can range from man in the middle attack to network congestion. There have been made various amendments in protocol to avoid the attack on MAC layer, but much success hadn't been registered till date. Talking about management frames enable stations to establish and maintain communication through each other. These packets are also used to support authentication, association, and synchronization. So, in this paper, we'll be talking about the authentication attack. So, subtype of the authentication and the subtype bit is 1100. So the authentication attack, what it does is it is a type of denial of service attack that targets communication between a user and a Wi-Fi wireless access point. When a successful authentication consists of two acknowledged authentications frame is completed, the client station requests for association. And furthermore, after association, whole authentication process is completed. But when a station wants to disconnect to a device, it sends a management frame with the authentication subtype, and the connection between those two is broken. Many security problems arise from the lack of protection of management frame encryption because these frames can be captured, MAC address can be spoofed, this packet can be faked, and then it can be rendered to the victim as a packet coming from the source. So research method that we use for construction of this paper and to analyze this further is penetration testing. To be more elaborate, we have used external penetration testing. It is a technique used for assessing, evaluating, and analyzing systems based on security and information system. The external penetration testing is security assessment of any organization's parameter system. It consists of all the devices that are reachable directly through the organization internet. So we are trying to check for our gateway as well as all the devices connected to gateway, whether they all are disconnected or not. The aim of such testing is to find meaningful and ambiguous ways to compromise the existing system and configuration. Penetration testing consists of planning, discovery, attack, and reporting. So our main tool we have used here for rendering the attack is IoT hardware, which is used to stimulate these attacks in the Wi-Fi access point. It deauthenticates all the devices connected to that particular access point. So access point is a target here, and IoT is a tool that will be used to stimulate the attack. The test data are recorded by using packet sniffer and analyzer. In this attack, the authentication frame is done by spoofing the MAC address of access point. After spoofing the MAC address, the frame is made by microcontroller, which is in our case is IoT hardware. The constructed frame is then broadcasted to all the nearby devices to disconnect from the particular network. So, for our research, the tools that we have required are for attacker tools. We have use a Wi-Fi module, popularly ESP8266 node MCU for mounting Wi-Fi module. Languages, programming languages such as C++ and Arduino for program development and compilation. The gateway we have used here, gateway is, we can say, it's a device that can send and receive signals according to IEEE 802.1 protocol. Our target here will be a smartphone that we're trying to disconnect from the gateway. We have also used packet sniffers and analyzers such as Conview and Wireshark to capture the packet in air, and web interface to specify and to see which type of BSSIDs are available and what are the MAC address that we're actually attacking on. So this is a test scenario for external penetration testing where our purpose is to prove DOS, the authentication attack. Start state is device is connected to an access point, and our end state is device is disconnected from the access point. Here we can see a network schema of our overall testing environment. Here we have a network analyzer and packet sniffing software, and we're also recording all the activity via ComView version 7. We have a wireless connectivity between smartphone Wi-Fi and our wireless gateway. We are working as a attacker, and here is our microcontroller, or we can say IoT hardware that will be rendering the attack. So once the attack is rendered, the smartphone is disconnected from the wireless gateway that we have here, and the packet is captured by ComView and it is sent for network analysis. All the activities has been between the Wi-Fi and the IoT device is monitored using Wireshark and ComView, and our display web display is also used to list access points, RSSIs, and MAC address, etc. So some of the basic requirements to render attack includes BSSID and MAC address of the device for which target needs to be disconnected. So as a result of that this testing, we have found that the communication of the target is lost with the gateway or access point. The MAC address of the device is still registered with the smartphone and is safe for future connections. The target tries to reconnect to the gateway access point but could not connect because of the attack. So as soon as the attack is stopped, it connects again to the gateway and it can again regain internet accessibility. The proof of vulnerability of IEEE 802.11 to the authentication attack is established by this penetration testing. The data revealed by the test is in the form of data which can be used to draw out conclusions. So we can see here the state conditions where we have a start state and the end state. What is the data rate, how it's changing, our packet types change from data to management. The subtype is for first frame is QoS null, but the second is the authentication. The basis IDs is not changed, source address is changed because of the attack. Destination address is still changed, sequence number is not there or it's changed. Here is a web interface of our product, so we can see all the networks that are available including their MAC addresses, so we know if we are choosing a correct spoofing network or not. We can also see in the below graph the change in throughput of the smartphone device throughout the attack. So before the attack it was working properly fine with speed, but as this attack started between 8 to 10 seconds, the throughput dropped completely and there is no throughput. But after 10 seconds, as soon as the attack is stopped, it again regains the connectivity and start working in its usual manner. So the conclusions that we can draw out from this product is that IEEE 802.11 are vulnerable to MAC attacks. The management frames are not encrypted and sometimes a true source is not identified. The management frames with subtype 0x2C can be transmitted over network using the same MAC address of the access point used by the target. So this attack can disconnect all the devices in the range of integrated IoT hardware, or we can say as far as the packet is reached from the IoT hardware, it can disconnect it. It can paralyze communication, and the network is totally out of hand, and the the to and fro packet transmission is stopped. So the future work should focus on mitigation of management frames without compromising the speed and accuracy of the current system. The research on the best configuration for the access point will also be very useful. We would like to thank all our references for helping out throughout this study, and